Hello, welcome all to this session and brief overview of Red Hat Advanced Cluster Management for Kubernetes, RHACM for short, then specifically for the open source Lisbon event. What is the thought process behind the existence of something like RHACM? So why do we need a multi-cluster manager? There are many reasons why organizations, customers need multiple OpenShift or Kubernetes clusters. The issue is that from the start, Kubernetes was always regarded as an atomic entity. So whenever you deploy a Kubernetes or OpenShift cluster, you're actually getting its own mini infrastructure. So it isn't really aware of other Kubernetes clusters, either close to it or geographically dispersed. So the reasons that lend organizations to deploy multiple clusters are various. Arguably, this slide has the most common ones like geopolitical and compliance standards requirements. Data locality for reduced latency. Geographical dispersion of applications for availability, and of course being able to vary your infrastructure costs will also help immensely with your CapEx overhead. So when you do this, when you actually sprawl out your Kubernetes environments, you are faced with, of course, an immediate decision-making process and also problem-solving one, which is, okay, so how would I then enable all these clusters to actually be abstracted from their own identity, and to my developers and to my DevOps people present a unified structure, something that is easily pullable, easily pliable, and like I mentioned, in the Kubernetes world by default, that isn't so. Well, the open source world has been long trying to address this, let's say, shortcoming, maybe, if I can put it like that. There have been many projects that have come and gone, to be quite honest, but some time ago, Red Hat started a project called OpenShift Hive. So a Hive is essentially this API that manages other Kubernetes APIs. So that's in conjunction with some other moving pieces what allows something like advanced cluster management to exist, in which we can now start to provide a very effective way of abstracting all my Kubernetes and OpenShift clusters and just presenting a single point of entry, a single point of control, a single point of inflection. So there are some interesting things that we can do with RHACM. We have, of course, multi-cluster lifecycle management. That is, I have the ability to create and destroy new clusters, to update them, to reshape the clusters, grow them or reduce their footprint across all clouds. I can also do this for some Kubernetes pure clusters out there. The thing is, what's most interesting about RHACM is that I can do this not only for OpenShift, but of course for other Kubernetes-based technologies. I can, for instance, import Google Cloud-based Kubernetes services. I can import AKS services into RHACM, and in that way I can, like I said, unify both our application topology. I can unify our monitoring and telemetry, risk management, as it says here, and most importantly, I do get the ability of always keeping my clusters, my Kubernetes clusters, in sync. So going back to the previous slide, I can actually now have a way with RHACM and its associated open source technologies to be able to give this gateway to both developers and DevOps in such a way that they can actually develop their code once, and then all the moving pieces behind RHACM, stuff like Hive, can actually go out and ensure that the placement of my configurations and apps is according to my specifications. So one slice of code, multiple Kubernetes OpenShift clusters. Now, this is a very simple overview of the possible architecture. We have always what we call a hub cluster, which is where RHACM itself is deployed, okay, where the brain of RHACM is deployed, and then we just keep on joining. There's no current limitations on the number of objects that we can actually add to RHACM. We have some sizing recommendations in our documentation online, but let's just say it scales rather nicely because of the way that a Kubernetes and OpenShift works, which is just API-driven calls essentially. So we have this, like I said, hub cluster, and then we just keep bringing on other Kubernetes technologies and or our OpenShift clusters. So unified cluster management, lifecycle management of all parties concerned. The policy governance, of risk and compliance is very actually nowadays with all the legal intricacies of the different countries and even different economic space or geopolitical spaces, there are a great many number of rules out there. Furthermore, Kubernetes and OpenShift, of course, allow us to do a lot of security tightening and security overseeing of our resources. So, we can have stuff like quotas and security constraints, and of course, load-based access control. I mean, there is a lot of stuff that Kubernetes and OpenShift allow, in which you, the user, can tighten, let's say, so to speak, the bolts of every part of your OpenShift infrastructure. So when you have a sprawl of OpenShift and or Kubernetes deployment, this becomes almost next to impossible because, again, this might be in different regions. It is since each Kubernetes cluster is its own entity, you have to actually maintain different security policies and compliance metering for all these infrastructures. So it becomes a rather daunting prospect. Now, with RHACM, we can actually, again, use these overseeing mechanisms that we have to have a centralized point of policy compliance and remediation. So you can actually, yes, go out and define a policy in the software. We'll do a brief overview of a demo system or a pre-release GA that we have that I have been able to access within Red Hat, and just to show how this works, but how easy it is. And because, again, we're not reinventing the wheel, we're just using the built-in mechanisms that come with Kubernetes itself. We're actually, everything is done via YAML, and the software makes sure that you as the operator actually have access to directly to the YAML, so that you can peruse the code and peruse the templates of what is actually going to be done in your OpenShift or Kubernetes clusters of choice with this module for governance, risk, and compliance. So, and this can run either in enforce or just warning mode. So it opens a lot of interesting possibilities where you actually go into the clusters and you just make sure that they adhere to your security and compliance constraints. Out of the box, we actually support a lot of the international standards like NIST, PCI DSS, and others. So you can actually just compare your OpenShift clusters directly against those. I mean, especially if you're in a very regulated space like government spaces. and infrastructures, but you can, of course, just make up your own policy that, it's a bespoke policy created for your specific environment. Actually, we can see here the type of objects that we can enforce or warn about. These have actually grown in the 2.1 release. This is a 2.0 documentation. So yeah, we can be very creative when it comes to, are my systems compliant with what I have defined? And again, just imagine the advantage of being able to unify this across, OpenShift clusters or Kubernetes clusters, the ability to make your configuration widespread among different availability zones in a public cloud, for instance. So a very powerful and very useful feature set. The other, and arguably probably one of the most important parts of RHACM, is the application lifecycle management. So whatever we do with the cluster lifecycle management, we can probably, let's say, increase it tenfold of what we are able to do with the application lifecycle management. Now, using a GitOps approach, we can actually give the developers and or the DevOps, when it comes to reshaping the clusters, and to the developers reshaping and or development and deployment of their applications, we actually give them the ability to, again, have a single source of truth, which is Git, and just do multiple deployments. The demo that I have here, we have several multi-cluster deployments, and they actually span to different geographical regions, so that's pretty interesting. But most of all, it just gives you this very clean approach where you have this central hive mind, pun intended, that goes out to your code, and then just via instructions in your YAML, it is able to target the different clusters that you have. Of course, your placement rules are entirely up to you, as are your replica sets, etc., etc. We really, like I said, not reinventing the wheel. We're just making a very effective use of the built-in mechanisms that we already have in the Kubernetes world. Now, this is interesting in itself because, again, it leverages GitOps very quickly. So it enables an operation, infrastructure, an entity, an organization to ramp up very quickly on their GitHub specification. Now, the interface does make this rather easy to consume, and it's, in 2.1 it has been refined immensely vis-a-vis 2.0, and of course we're going to continue on that path by consulting, as usual, our users, the developers that use our platform, and asking them, point blank, okay, so what can we improve on this? Besides the inputs from our own engineering, we always rely on the inputs from our customer user base. So very, very cool way of rapidly doing multi-cluster, multi-Kubernetes deployments. This is just an example of it that we can't really, I'm not going to import an existing cluster, but just to give you an idea that the 2.1 specifically, we can now provision to bare metal and also vSphere environments. Let's just create an OpenShift either on bare metal and vSphere led environments. And we can import EKS, AKS, GKE, IKS, and ROCs. So very complete, like I said, having a single pane of glass to just, manage all your Kubernetes services regardless of where they are. Very important, we integrated, so in 2.1 specifically, we integrated the Thanos project. So Thanos is a Prometheus of Prometheus, so it's a project of the Prometheus community that actually is able to scrape other Prometheus sources and then, centralize everything in one location. So very powerful, and this, of course, allows again the RHACM users, specifically the Lifecycle cluster administrators, to have an overall view of their data. So a single actually Grafana instance allows them to have this very holistic view of what's going on in the different clusters. So usually you have to go either to the public cloud services and telemetry of those specific cloud services to see that, and or of course in the case of OpenShift, you have to go to each OpenShift console and access its telemetry and monitoring sub consoles. So Grafana, Prometheus, and all of that. With this, again, a single point of inflection for all our telemetry. So it's very useful, in particular if you want a clear overview of your data, regardless of where it's situated. Now, up until now, we've been always talking about Kubernetes and Kubernetes. So yes, we do all this stuff, policy management, lifecycle of applications, lifecycle of the clusters themselves. But this is always within the constraints of the Kubernetes world. So very, very, that's well and good if you don't have to interface with third-party systems and or third-party devices. But of course, we know we usually have to. So in 2.1, we're introducing the tech preview. Tech preview is the nomenclature that Red Hat applies to a feature set that can be already tested and tried by the customers and our users, but is not actively supported by Red Hat. So from tech preview, it goes to GA when Red Hat considers it to be stable and performance enough. But right now it's in tech preview. But what the Red Hat Ansible Automation Platform integration does is, as you might have guessed, we interface with Red Hat Ansible Tower. So we can have pre and post application interfaces or hooks. So in the example that we have in the UI that I'm going to show you very quickly is that we're deploying an application to two different geographical placed OpenShifts. And so how do we load balance this? Of course, we load balance this with the GTM software. We balance this with an appliance of some sort that does global load balancing. So in this example, we actually go out to an F5, which is the global load balancer elected for this demo. And whenever we deploy the application, there's a pre-hook and post-hook of Ansible that goes out to the F5 and inserts our environment variables that pertain to IPs and what VIP to create. So with this new approach, we can actually go outside of the Kubernetes native world and interface with whatever we want. Of course, a GTM is just one of the examples, because we can, of course, talk to firewalls. We can, even something as simple as send a Slack message or a WhatsApp notification, an SMS gateway. The possibilities are endless, because Ansible itself, right now, it interfaces with most technology verticals that you can find in the data center. So we can go full circle, which is pretty impressive. So again, in your development and lifecycle of your application, you can now actually bring in whatever external to Kubernetes entity you need in order to make this happen. And of course, this can even be something as simple as, okay, I'm going to announce to my ITSM that I've just deployed an application or a new node. So a hook, an Ansible hook, goes out, for instance, to ServiceNow or Remedy and says, I have a new application. So very effective in the way that we can handle application and lifecycle management. This is just an architectural overview of how it works. We use operators to do this. So very clean. Again, it's in tech preview, as the slide mentions, but we're getting there. And so with this, I'm going to jump into the interface. We have about 10 minutes of allotted time, so I'll just go run through this quickly. So this is our main page of RHACM. So we have end-to-end visibility. We can click on it and go to overview. And this is the place, of course, where we have all the what's up and what's down, how many services we have. We can show details. of the objects per clusters, the regions, if in a public cloud. This is all public clouds in this case, so yes, we have regions for everything, number of nodes, number of pods. We can have, if our clusters are compliant with defined applied policy or not, how many pods there are in total, and the cluster status, how many of the clusters that we added are offline and or are ready, of course, for our consumption. Now, in the provider connection, you can see that we have all these infrastructure providers. Like I said, we can manage EKS, AKS, OpenShift itself. So very, very complete, and of course, nothing really is keeping us from adding more in the future. So the bare metal one, for instance, is one of the most interesting ones in RHACM 2.1. So what else? We have the compliance, of course, but over here at the top, we have, of course, search. Search becomes very important, probably one of the most important features, which is kind of ironic because, of course, if you have sprawl and you have millions of objects across different OpenShift and Kubernetes objects, how cool is it that I can really search across all these environments and find a specific resource? So usually, again, this will be a very difficult task, but using Hive, it becomes just a run-of-the-mill experience from the operator standpoint. So that's pretty cool. We can go back. Of course, we can create new resources, but there is a submenu directly for that. We'll show that in a minute. And there's even a tech preview of a CLI interface to the cluster. So that's, again, pretty cool. So I won't have to actually, if I just want a quick and dirty command, the RHACM just logs me into the cluster that I chose to do this, and it allows me to input direct OC commands or kubectl, whatever. So again, I don't have to SSH directly into my API because, again, I can be in a very different geographical zone. I might not even know the API URL, although it's pretty easy to achieve that with RHACM. But again, very cool for a quick and dirty approach to. I just want to log into my cluster, do some quick commands, and it shows me this in a very nice, organized manner. So I'm going back to home. And so that's end-to-end visibility. Again, here, because this is pre-GA software, I'm afraid the Thanos module isn't actually installed, but it of course will be in the GA version. So we have cluster lifecycle. So everything that pertains to deployment of clusters, deleting of clusters, attaching and detaching clusters, existing Kubernetes like AKS, and also creation of new ones and upgrades. You see here, for instance, these two are ready for the upgrade. I could just click from the central location and just do the upgrade for whatever version I deem fit. So again, very easy, very single pane way of glass of doing this stuff. And of course, at cluster, I can either create or import, okay? But for instance, in the ones I already have created, you can see it has all this very useful information. It gives me the list of nodes, and it gives me the cluster settings where I can actually drill down into them. Well, it's not working right now. But if I go back to overview, reveal credential, we're not going to do that. But it says also to me that there are no applications that were deployed via RHACM, but it says also that there are 2 policy violations. So I can download the configuration both of kubeconfig and the install configuration, so it's very easy to replicate, and I can edit labels. This is especially useful, of course, for placement and for searching of resources. Launch to cluster, I can upgrade cluster, and I can detach it. Detach it it's what it means. I mean, I would remove it from the Hive API management of RHACM, and the cluster would still exist. Destroy cluster, as the name implies, will actually destroy the cluster. So very easy to do cluster lifecycle management, and again, like I said, I can actually come in and create a new cluster. So if I come here and add cluster, create cluster, and it gives me all these very nice laid out options where I just click on the infrastructure that I want, and off it goes. The releases, the base DNS domain, and it just does everything else for me. It goes out, talks to the API in question, if it's a public cloud, if it's bare metal, if it's VMware vSphere, it talks to that API and just deploys my OpenShift cluster. So the governance and risk, as the name implies, is the policy and compliance part. So very, very useful for, are my clusters keeping up the code that I defined? Do I have role-based access control violations? Are the authentication sources configured as I determined to be so? Do I have, let's say, extraneous users on the platform that it should? Is it compatible? Is it compatible with information processing procedures? So very, let's say, interesting and powerful features. So I can, of course, order it by cluster violations to say, okay, what's happening here? What's the transgression that you're, of course, identifying? But in this case, we really don't have the time to go into it. I can actually, like I said, create a policy. Again, it will present me as this wizard-like process with all the YAML definitions on the side. One of the interesting things about create policy is that I can actually zero in on a namespace or an application. So it doesn't have to be a cluster-wide policy. It can just be a specific application and or everything that's in a specific namespace. So very, very interesting. And last but not least, of course, application deployment. So application lifecycle. Like I said, it's a GitOps approach. Now, we're not using Argo CD at the moment. For those that know what it is, we're working towards that. I mean, engineering is trying a great many things so that we can, give more options and make the developers and DevOps lives easier. But so we're working with stuff like Argo CD. We're working also with Submariner to eventually onboard it into RHACM. So very, very interesting, very exciting developments on all those fronts of multi-site application deployment. But for now, we're just using a GitOps approach. Of course, we can and we should, when we start working with this, to use pipelines, namely Tectod. It's very easy to do so with RHACM. But in this specific case, so if I do a create application, of course I can do enter a name. I can select a namespace and I say which type of, as you can see, we can use a pre-existing Helm chart, our Git, object storage repository. I can do Helm, and so where are our shards, what's the shard name, package versions. Now over here, very, very cool, that's where you start to go into the cool aspects of RHACM. So select an existing placement configuration, okay, something that I already defined. So I want these applications here and there, or deploy on the local cluster, deploy to all online clusters, deploy to application resources only on clusters matching specific labels. So very flexible in the way our application deployment is going to run, and we can even define a time frame for this. Again, most of this stuff will be done via the pipeline, but it's actually very interesting that it's just a single click operation here, and your operation just goes out into whatever clusters you decide. So let's look at the Pacman app. Like the name implies, it is a Pacman app. We have here our Git repository source, so our GitOps single truth source, but we're just going to look more into the application topology. And like I said, this is a multi-cluster deployment. It goes to the Quebec Alpha and Quebec Bravo clusters, and it's as the name implies, it's a Pacman console, like a based console pacman. We have the application itself. Of course, I can always see the resource YAMLs. You can see we can jump right into the resource YAML and just, the developer can have a look-see at what is happening here. We have the Ansible jobs with the pre-hooks and post-hooks. Again, what this does is actually go out and creates the records, the DNS records, and also talks to the F5 in order to update the load balancer and say, okay, here is the new application. It's spread across clusters and off you go. And so all our resources are here. And I'll just, as a last step, I'll just show you the route, that is the pacman application itself, and here we are. So, and curses kind of pacman, and just playing pacman. I haven't played this for years, so I rather suck. But so very easy, let's say, to have overall visibility over your applications. Of course, I can change this YAML at any time via the Git repository, and I could just trigger any changes to the Hive reconciliation sets and just repurpose and refactor whatever I wanted, and it will always land in the correct places. So with this, thank you. I hope this has been helpful, and of course we are at your disposal for answering any questions. Have a nice day. Thank you.